Welcome to the lecture series on policy gradient methods in artificial neural networks. In this video, I cover how to go from batch to online using the log likelihood trick. So, for policy gradient methods, we want to optimize a mean reward, which is averaged over the different starting states, the different policies in the different states X, and what we really average is the reward R of Y and X. Now, to optimize this, we need to change the parameters and in a way so that we maximize the reward. And now that would lead to a batch rule. Now the question is there an elegant way to keep a correct statistical weight when we average in the online mode? We will have a gradient. We have to average over the gradient in an online mode. And this is what we are going to do now. So this is my mean reward. It depends on the parameters. The parameters are the little index indicated by the little index W, the blue weights, And now let's change one of the weights and say delta Wj is alpha times the gradient with respect to Wj of this average. So we copy this, it's sum over x, sum over all possibilities y, and there's the p of x. Then I leave a little bit of space. I have my p of y given x, which depends on w, and then I have my r of y and x. And I said this policy depends on the weights w, and I take the derivative with respect to one of these weights, wj. So, and this is the averaging. Now, what happens is that the statistical weight in the original formula is p of x times policy p of y given x. Now, if we have here the derivatives, it's no longer the correct statistical weight. I need to bring it back in. And the way I do this is I say, well, let's multiply with a factor of 1, and I just write in here the p of y given x, and I divide by the p of y given x, and this policy depends on w. And now I take the denominator here and I combine it with this derivative, and I say, well, this is actually the dwj logarithm of p of y given x, and this policy depends on w. And then I can copy the rest, sum over x, sum over y, p of x, and then I have from the red term up here, I have the policy y given x, which depends on the weights w, and at the end I still have my r of y and x. And now I said earlier that the correct statistical weight is p of x times policy p of y given x. And this is now what I have here. So this is the correct statistical weight. Now if I take an online approach, I would say, well, let's just cut out these summations. Because if I take different stimuli x, I take them with probability p of x, and then the transitions to the actions y are generated automatically in the process of online playing the game. So all the statistical weights will be correct. And therefore, I arrive at the online rule delta wj equals alpha. And then I take the reward part, r of y and x. And then I take the green term here, e dwj logarithm pw of y given x. And this is the final result. What you see in this online rule, what matters is the derivative of the logarithm of the policy. I call this rewrite the log likelihood trick. It's my name. It's not standard. The method is standard. The method is used in many, many different areas of science. And so if you look up textbooks on reinforcement learning that cover policy gradient methods, what you will see is that many algorithms contain this derivative of the logarithm of the policy.